All right, you are welcome to another session. Here we want to find out how we can find the mass of the limiting reagent. We want to find out if you've been given a chemical reaction, how do you get the mass of the limiting reagent and how do you get the mass of the excess reagent. So we'll explore those fields and we'll discuss very important principles that we need to use for us to understand how we're supposed to work out these kind of questions. So the question is saying, the question is saying, consider the reaction, and we've been given to say the masses of these reactions. We've been given 18.1 grams of ammonia, which is reacting with 90.4 grams of copper oxide. Then they're saying we need to predict the limiting reagent and the mass of the N2 that is formed. So the question is not very difficult. We just have to understand how we're supposed to go about it. And here we go. Let's get into it. All right. So remember, we're talking about the limiting reagent here. So we're talking about the limiting reagent. We want to know how we can get the mass of the limiting reagent and how we can identify the limiting reagent in that chemical reaction, the one that was in excess, and how we can obtain the mass of the products that will be given in that chemical reaction. So we want to look at three things. We want to look at the limiting reagent, the one that was in excess reagent, and we also want to look at the amount that was in excess, that was in excess. So we want to explore these important fields, and also we want to look at the amount or mass of the product that will be formed in that chemical reaction or product. So these are the three things that we want to look at. So if you look at question 7 there, we've been given to say the chemical reaction that we're looking at here is this. So chemical reaction, we've got ammonia, NH3, these are grams, plus this is the calcium oxide. Then we're being given N2 plus 3, that's the copper there, and then plus the 3. Okay, that's what we've been given there. And of course, we know this was a gas, and we know this was solid. So we want to see how we can find the limiting reagent in this chemical reaction, the one that was in excess, and the mass of anything that was formed on the side of the product. So remember that we've been given vital information that we have to use for us to make it possible to calculate those limiting reagents. We are given to say here we're given 1.8 grams of NH3, and also we are given 90.4 grams of calcium oxide, of copper oxide. So out of the chemical reaction that we have here, and us being given the grams of NH3 that we were given, that should not take place in a chemical reaction, but that is what we were given in that chemical reaction. And the 90.4 grams of the copper oxide was what was taking place in that chemical reaction. So Basically, for us to find the limit in reagent of this chemical reaction, or the one that was in excess, we need to find out how much was participating in this chemical reaction, how much NH3 was reacting with the copper oxide to produce the products, or how much of the copper oxide was reacting with the NH3 in order to produce the product. So we have to find those values and look at how we can balance them from this angle. So before we do that, let's find the molar mass of NH3. So finding the molar mass of NH3, you get it from the chemical reaction that is here. So I'll take it as a O, which is 2NH3. So you're going to have 3 times 2 times 1.008. You have your value there. And then this is just 2 times 14. I'm just using the normal figures, but there's a recommended periodic table for you that you have to use and make sure that you are good in terms of your precision and accuracy. So I'm getting this as 66.04, and I'm also getting this as 28. So to find the total there, I'm getting 34.04 grams per mole. So this now becomes my molar mass of the 2NH3. So let me also find now the molar mass of the copper oxide. So I remember you are taking it as a O from the chemical reaction, CO3. So you multiply that, this becomes 3 times 16. And then for copper, you know that the mass number of that becomes 3 times 64. So you get 48 there, and then you get 192 there. To find the total, you get 240 grams per mole. So that is what we've been given there. So we should know that this is the molar mass of the copper oxide, and what we found previously was the molar mass of the NH3. So this is how we're supposed to work them out. And upon finding this, we now need to find the masses. How much of the NH3 was participating in this chemical reaction, and how much of the copper oxide was participating in this chemical reaction in order to have the N2, the nitrogen gases, the copper, and the water that was formed in form of gas. So how do we work out that? That is what we're about to do now. So you see that we've been given 1.8 grams of that, and this 1.8 grams of the NH3 that was given was equal to the molar mass of what? It's equal to the molar mass of 34.04. 34.04 grams per mole. So we know to say this is the molar mass and this is the actual mass of the substance or of the compound. So we want to find out the actual mass of what molar mass? Of the copper oxide. So this becomes 240 grams per mole. What becomes the answer? So when you cross multiply there, you do that, you discover to say your value of x turns out to be 12.69 grams of the copper oxide. So the 12.6 grams of the copper oxide was what was taking place in this chemical reaction. Let us look at what we were given. In this chemical reaction, we were given 90.4 grams of the copper oxide as what we needed for this chemical reaction to take place. But what did we have? We had 12.69 grams. So we were given more than enough. So this is true enough, and we can make our conclusion from here that this was in excess. This was in excess, and of course, when you know that one part of the reactant was in excess, you can make the conclusion to say the other part of the reactant was what? Was limiting. So we can still find that and see how we can get to the next level. So remember, we had 1.8 grams of NH3, And what was the molar mass of NH3? The molar mass of NH3 was 34.04. And of course, we won't use this. We'll use the conversion for the copper oxide. 1.8 grams of copper oxide um, being equal to what? We use this one here. 90.4 grams of the copper oxide being equal to its molar mass. 90.4 being equal to 240. So that is what we have there. 90.4 grams being equal to 240 grams per mole. So we want to find out the molar mass here, or the actual mass, sorry. And then what is the molar mass of what we are finding here? This is 34.04 grams per mole. So how much do we need here? So the value of x there now becomes 12.82 grams of what? Of the 3 of the 2 NH3. This is what was taking place in this chemical reaction. So now we have to look at what we are given. What were we given in this chemical reaction? We were given 1.8 grams, and we need 12.82 grams for this chemical reaction to occur, or for the NH3 to react with copper oxide to form the product. This is what we need. So what does this imply? It implies that this was very limiting, and this was our limiting reagent. So basically, that's how you get to find the one that was limiting and the one that was in excess. So sometimes they phrase questions differently, and on the other side, you might be told to find by how much was it in excess. So to find by how much was it in excess, we just come here. This is what was in excess. I mean, this is what we needed. 12.69 grams, but we are given 90.4. So the difference between 90.4 and 12.6 grams is how much was in excess for the copper oxide. So this is how you find out the one that was in excess and the one that was limiting. So whenever you're given any kind of questions, any chemical reaction with given masses, just take the following procedure and see how you can arrive at a point where you can find the one that was limiting and the one that was in excess.